So we have the pleasure of Mary Silby, who is the, let's go to the next slide. She works for US Ignite, and she has been the main person for all these platform for advanced wireless research testbeds. There are 4 or 5 of those, and she's going to talk about it. And you've also been responsible for many of the NSF, the Overcome project, is it that?
Oh, yes.
Yeah. And she has been also a speaker in many of the IEEE conferences, even using the fast responder workshop that we do this time is happening in December 5th, to keep that deadlocked. So I'll hand it over to Mary to talk about what we are doing as part of NSA PAWR projects and how it's going to help accelerate the ORAN deployment and experimentation. Thanks, Mary. You have 20 minutes. Yeah.
Great. All right, I'll keep an eye on the clock. Thank you. It's a pleasure to be here. Thanks again for inviting me, Ashutosh. So as the title of the talk suggests, I'm here to talk about the Platforms for Advanced Wireless Research program, but specifically the Open RAN and open source activities and resources available through these platforms. I'm very grateful for some of the earlier presentations because they laid the groundwork for some of the things that I will talk about here as well. I also am kind of under the assumption that many people are familiar with the PAWR testbeds, but I will give a very, very quick overview before moving into specifics around ORAN and open source. So first of all, the PAWR program was created by NSF. It was created to produce 4 large-scale platforms or testbeds for advanced wireless research with the goal of maintaining US leadership in advanced wireless networking innovation. So specifically to lower the barrier to entry for people to come and develop and test and continue to further what our wireless networks can do. The project grant that started the program included not only funding for these actual platforms, but also for a project office to manage the program, which is where I come in. The PAWR Project Management Office is co-led by a team from US Ignite, which is my organization, and our colleagues at Northeastern University. It's also important to note that we had an industry consortium of partners that contributed significantly to the deployment of these platforms, contributing hardware, software, sometimes cash, and also engineering expertise. So we are very grateful to those partners. Okay, so thanks to the PAWR program, we have 4 large-scale outdoor deployments today, testbeds. There's Powder in Salt Lake City, which is focused on fully programmable end-to-end networks. Cosmos in the West Harlem neighborhood of New York City, also focused on programmable networks, but with a specialty in millimeter wave technologies as well as programmable optical backhaul. AirPaw in North Carolina is the conjunction of wireless communications with unmanned aerial vehicles or drones. And then ERA is our latest rural testbed that's up in central Iowa. Some very exciting things going on there, so I'm going to get into some of those specifics as well. Also worth mentioning that the PAWR program inherited Coliseum, which is the massive RF emulator that was used as part of DARPA's Spectrum Collaboration Challenge, which gosh, ended now 5 years ago, but because there's a pandemic in between, it seems like longer. In any case, we inherited the infrastructure as part of the program. It's now hosted at Northeastern University, and the reason it's relevant to the PAWR platforms is because users can test and run scenarios in emulation in this massive emulator, and then port those experiments or scenarios to the testbeds. Okay, so by their nature, the platforms are designed and built to enable open source development. They provide access to functions normally locked up in proprietary systems, which gives enormous flexibility to tinker with parameters to understand how these networks can be better optimized, sliced, new features introduced, and innovation furthered. As it happens, so the program started around 2017, 2018, and as it happens, we have seen the uptick in interest and activity around open source mobile software stacks at the same time that we were seeing these platforms being deployed. So not shockingly, a lot has happened in the last 5, 6, 7 years, and the platforms have had to adjust to meet the needs and the continuing changes that are happening in the wireless community. One of those big changes is the increased development, again, of those open source software stacks. As we saw somebody mention earlier, two of those critical ones are SRS-RAN and OAI, or Open Air Interface. And there's a lot of collaboration that is now taking place between those software communities and the teams at the PAWR platforms and researchers using these test beds. In addition to open source, the platforms have become important testing grounds for Open RAN development. All of the PAWR platforms are now, including a component of the Northeastern infrastructure, are now designated as OTICs, or Open Test and Integration Centers, by the ORAN Alliance. They are longtime participants in these ORAN Plugfests, and there are multiple OSC, the ORAN software community projects, that are taking advantage of the test beds to continue to test and develop those features within Open RAN. All right, now I'm going to get into some of the specifics at the different platforms. The platforms are very different, and I also am focusing on some particular areas. So there's a huge amount of information. I'm going to try to distill down certain things, but if people are interested in other avenues or something that I say sparks something of interest, please come find me so we can talk further about it. This is PAWR, so just to give a sense of what the test bed looks like. They have an indoor over-the-air lab where testing also runs, but then they have this large outdoor deployment that you can see in the map here. And it includes fixed base stations. They started out with 8 rooftop base stations. Those are their blue squares up there, outfitted with software-defined radios. And then in their second phase, they deployed 6 additional base stations, also SDRs, but with new RF front ends. And those are the green circles that you see. And this is the reason they did this is to create a dense cluster to be able to do some more specific experimentation, but also to be able to interact with mobile units, mobile nodes, which have been placed in campus shuttles that are traversing the area, as you can see by some of the green and orange lines there. So the platform is built for both fixed and mobile wireless research. Okay. That's the hardware, but what does the hardware actually enable? This is a huge eye chart. You're not meant to go through all the details here or try to collect all of this information, but we have these charts. We created these architecture charts for the different platforms in order to show how the different hardware components marry up with the software that is supported on the platforms, and then what types of capabilities and research avenues they enable. So again, this is available. If you want to go to the PAWR website and see these architecture diagrams for the different platforms, you can. It is advancedwireless.org, and we will try to keep these updated. This is from the spring, but it is still relevant today. The one thing I will mention on here as relevant to this conversation for PAWR is the support for both the OAI and SRS-RAN latest 5G software stacks, and also the 7-2 split architecture for ORAN, which they are enabling for use with testing with commercial ORUs. Speaking of the ORAN testing front, I mentioned that PAWR is one of the OTICs. There's lots of flexibility for folks that want to test or do demos as part of these Plugfests. You can come in and use PAWR, use different resources on the platform, the open source software stacks, the hardware, but you can also bring your own equipment, which often happens, whether it's hardware or whether, for example, it's distributed software, your own distributed DU or CU stack to be deployed on the PAWR compute infrastructure. And to give an example of this, Mavenir is currently testing their, this is not part of a Plugfest, I think, but they are currently testing their millimeter wave radios with their own virtualized CU-DU software, again, on the PAWR compute infrastructure. So it's a great platform for being able to enable that in an outdoor at-scale environment. Another thing PAWR offers is its test orchestration, test automation framework, or TOTA. This is integrated with testing software and lets you set up automated testing workflows, including ORAN test scenarios. So I know there's some Keysight folks in the room. This is integrated with some Keysight equipment and software. And this is going to be important for sort of iterated or repetitive testing because trying to set those things up, trying to do the setup manually each time is obviously very time consuming. PlugFest, again, PAWR's been participating since 2021. And again, you can do limited integration with the existing resources that are on the testbed if you are participating in a PlugFest on the platform. This can be as little as using their, their racks, their compute racks and their power, or it could be, far more significant using the hardware and software resources that are available and the TOTA framework. And last for PAWR, I just want to mention one of the test scenarios they ran at the Spring PlugFest, Spring ORAN PlugFest, just a few months back. This was in conjunction with the SRS RAN development team. They showed an inter-DU handover, mobile handover, take place on the PAWR testbed. This is done indoors, I believe, in the spring, but they are moving it outdoors. As far as I know, well, I can say that SRS RAN has only recently enabled the mobile handover capability. So this is a thing they came to PAWR specifically to be able to show how that could work using the open source stacks. Okay, Cosmos. So that was PAWR. I promise I will speed up here a little bit. Cosmos is the platform that is located in New York City. It, of course, draws a lot of interest because of that urban environment. They have a significant indoor testbed, sandbox environment with a number of programmable radio nodes, lots of compute power, et cetera. But they also have outdoor nodes and a dark fiber link that is programmable. So that has enabled a significant amount of research and publications that you will see out there from Cosmos. ORAN capabilities, they were actually the first of the PAWR platforms way back when to be designated as an ODIC, and they have been participating also in the PlugFest since back in 2021. Some of the applications that they have demonstrated, because they participated in proofs of concept as well as specific testing and interoperability testing. There was an energy savings application as part of one of the earlier PlugFests a couple years back. And then there was one which Tracy Van Brockel, if she was here, could tell you about in more detail, a significant proof of concept where they showed the possibility of creating a network slice across what would essentially be two different carrier SMOs to be able to prioritize emergency network traffic, so think public safety. The last thing I'll mention on Cosmos is that they are also part of Accord, which is one of the projects that was funded by one of the major projects that was funded by the NTIA's Wireless Innovation Fund, the goal of which is to accelerate Open RAN deployment or ORAN deployment. So this project is led by AT&T and Verizon. It was a $42 million investment. Cosmos is one of the platforms, one of the test beds that is being used to run tests and to do development as part of that project. Okay, AirPod, this is, at least visually, the sexiest platform for sure. So this is a platform that uses custom unmanned aerial vehicles or drones in conjunction with largely programmable hardware and software. They have a primary outdoor deployment that is a flight field with multiple fixed node base stations and these custom drones. Again, largely SDR radios, largely software-defined radio based from the infrastructure perspective. They also have a digital twin environment with not only that open source software, but also drone vehicle control software. So it's a place you can marry those two things together and run scenarios based on what would be at that field or at that outdoor deployment, run them in the digital twin environment first before moving them to the outdoor test bed. This is what that flight field looks like. You can see the 5 red towers. They expanded from one solitary tower to now 5 different towers, significantly expanding the coverage footprint. In addition to drones, they also have an unmanned ground vehicle to cover the terrain at ground level. And then obviously a number of other sensors and some IoT equipment as well. Oh, I should also mention they also maintain, for drone experimentation, pilots and flight waivers and such, because they need to actually conduct the experiments for researchers once they've been run through that digital twin environment. So they have the legal way to do that and the regulatory waivers needed to be able to do that. Now, AirPaw is relatively new to the Open RAN space. They were only designated an ODIC earlier this year, and they will start their activities with the fall Plugfest. They're planning to start with ORU conformance tests in their lab, but in the future also integrate RIC testing. And I also think it's worth noting that NC State, which is where the platform is based, recently recruited Dr. Vijay Shah, for those who know him, who has a number of his own ORAN projects, and he will be working alongside the AirPaw team as well. Last but not least is ERA. This is our rural platform. It's pretty extensive, and it's also highly multimodal. It's got a number of programmable elements, not only NI SDRs deployed everywhere, but also Skylark, some Skylark massive MIMO arrays with some new open APIs that are operating in the TV white spaces band. And then uniquely to ERA, they also have a deployed commercial-grade 5G network that is powered by Ericsson radios. So this is 4 nodes specifically designated exclusively for research purposes to be able to do more application-level research and targeting precision agriculture applications. One thing to highlight here on the programmable side too, so they also support both SRS-RAN and OAI. On the OAI front, they are, as far as I know, the only large-scale deployment of end-to-end OAI, the end-to-end OAI software stack. So it's open source from the core to the base station function all the way down to the UE code, which is deployed on software-defined radios. Again, I think this is unique, and as we've seen from the usage stats, that's one of the most popular resources that researchers are using. This is a little bit of a sneak preview because those green circles are the first 4 base station towers, massive cell towers, that the ERA team deployed. And next week, they are actually unveiling those additional 3 yellow base station sites, which significantly expand, obviously, the coverage area. And those also support long-haul microwave wireless links for some further investigation into how to optimize wireless backhaul for particularly rural areas and sparsely populated areas. So if you happen to be in Iowa next week and you want to join us at AeraFest, where they will be unveiling their second phase of operations, it's also coincides with the Farm Progress Show, which is a major ag tech show right up the road, and they will have some agriculture application demos there as well.
You have a registration for that, right? You just log in.
Yes, and I think there is a significant portion that will be available online as well. If you go to erawireless.org, you will be able to find information there. Finally, on the ERA front, they've engaged and are engaging in numerous ORAN activities. They also relatively recently became an ODIC, will participate in the fall Plugfest. It's also interesting, I only recently learned significantly more about the Ether project, which from the Linux Foundation, which was presented earlier, and I have learned that there's a collaborative effort. He mentioned PAWR earlier, but they are also looking at getting the Ether deployment up and operational at ERA as well. So that includes their state-of-the-art near real-time RIC, open source near real-time RIC. And then also ERA, in addition to Cosmos, is one of the testbeds that is supporting the Accord project. All right, last thing in my last minute. Again, I've spent the time talking specifically about Open RAN and open source capabilities and the things you can do on these platforms. There is a lot more to discuss as we're talking about looking forward to 6G and beyond. One of the big topics, obviously, is spectrum and how we manage spectrum in our networks. The platforms are significantly valuable resources for trying to determine some of those things, whether it's collecting data from the a live RF environment to do things like train your AI and ML models, but also as test beds to support development of new spectrum management technologies. So as an example, PAWR has developed their own zone management system as part of another NSF project, and the implementation there is to have a system that takes the stakeholders in a geographic region and lets them request spectrum from the spectrum incumbent and determine based on policies and such how that spectrum can be dynamically allocated. So that has been created. They developed or presented a paper on this at DISPAN back in May and are going to contribute it to the open source community. And that's it. That was my full 20 minutes. I am around, so I'm happy to take questions or talk further later on as well.
Silby, available any immediate questions somebody wants to ask? Yeah, go ahead, please. I need some student volunteer.
I am a member of the Ensign cohort for this year.
Sorry, the which cohort?
Ensign, National Security Innovation Network
Gotcha.
cohort. Do you guys provide any mentorship or guidance for those entrepreneur groups?
So because these came through, because the platforms came or grew up through NSF, they have focused very heavily on being training grounds for academics through things like their REU training systems, et cetera. That said, they are excellent training systems that can be used. They've started to develop, some of them have started to develop curriculum models, for example. So there are ways to think about how we could bring entrepreneurs and just in general train a workforce. I think that is something that has not been leveraged enough for the test beds. Again, I think that content has been developed. Have the connections necessarily been made to enable that? No, but I would love to talk to you about it if you're interested.
Yeah, Mary, thank you again. So I also like to just remind folks, this IEEE 5G6 innovation test bed we have talked about. So we are at a stage right now, hopefully we can be part of the ecosystem.
Yeah.
We can talk about that later. Brad is
Great.
here. There'll be a talk also later on. So with that, just a small...
Oh.
You published the architecture. Are the what you need to actually do work published?
Sorry, what's needed to actually...
If I handed that architectural diagram
Yep.
to a graduate student, they would not know what to do. Is there more is the level of detail of...
Yes, so all of that is meant to give you an overview of what's available. All of the platforms have user manuals that are specific to, here's how to engage with the platform and here's how to access.
And can you engage from outside the US?
Yes, you can. The question is, oftentimes, depending on the project, how the funding works.
Yeah. I also suspect you have a lot of papers published, right? I often go to your websites. A lot of interesting papers, yeah. All right, Mary, thanks again.
Okay,
as always.
thank you. I'm going to hide this one. Oh, thank you.